Hello and welcome to this undergraduate skills video where we're going to learn about various basic laboratory calculations which will be extremely useful as you progress through your degree. Now, why do you need to know about these calculations? Well, it will allow you to safely dilute solutions in the laboratory whilst ensuring your experiments are at the correct concentrations. So without further ado, in this particular video, we're going to focus on how to calculate the dilution of a solution. And in order to talk about this, we need to understand what it is to be a solution. In its most common form, a solution is a liquid made up of two components. The first is the solute, and this forms the minor component of the solution. Essentially, it is being dissolved in the solvent, which forms the major component of the solution. Therefore, something can be both a solute or a solvent, depending on if there is more or less of something it is being added to. Now, the amount of solute and solvent present within a solution determine the overall concentration of the solution. Essentially, this is the amount of solute per known amount of solvent, and it's important for us to know the concentration of solutions in almost all of our practical applications to ensure that we are safe in the lab and to give meaning to our observations. Now, when there is a high amount of solute dissolved in a solvent, we would say the solution is concentrated or that it has a high concentration. When there is a low amount of solute dissolved in a solvent, we would say the solution is diluted or that it has a low concentration. In both of these examples, concentrated and diluted are relative terms which can be used as verbs. So as an example, dilution is the process of decreasing the amount of solute per solvent within a solution so that it is at a usable concentration. Now, this can be achieved through many different methods, and in this video we're going to look at how we dilute a concentrated solution to a specific concentration that we need for an experiment. And obviously this revolves around a very specific equation, which doesn't have a specific name. It is just known as C1 times V1 equals C2 times V2. And this is where C1 is the concentration of our stock solution, V1 is the volume of the stock solution, C2 is the concentration of our diluted solution, and V2 is the total volume of our diluted solution. Now, using basic algebra, we can rearrange this equation so that we can take three pieces of known information in order to identify the fourth unknown. Now, one of the most common scenarios where we use this equation is when we buy in a stock solution from an external company that has a relatively high concentration, but we need a specific volume at a lower concentration for a particular experiment, and so quite often it's easy to identify the three pieces of information. Now, to help make sense of all this, we're going to look at two different examples. In our first example, a student buys a concentrated solution of antibodies which has a concentration of 250 milligrams per milliliter. And for a particular experiment, they need to create a 7.5 milligram per milliliter solution, but they don't want to dilute the entire stock solution as they only need 5 mils at this concentration. The student therefore wants to know how much of the stock antibody solution do they need to create a 5 milliliter solution at 7.5 milligrams per milliliter. So in order to do this, we need to bring up our equation whereby C1 times V1 equals C2 times V2, and then we rearrange it using basic algebra in order to find V1, which is our stock volume, giving us V1 equals C2 times V2 divided by C1. We can then transfer all of the information we have from our example question into our equation, giving us V1 is equal to 7.5 milligrams per milliliter times 5 milliliters divided by 250 milligrams per milliliter. Now, to help make things easier, we can simplify this equation by completing the top line of the equation, giving us 37.5 milligrams divided by 250 milligrams per milliliter, which we can then complete to give us a volume of 0.15 milliliters, which means in the 5 ml solution we want to create, we would add 0.15 milliliters of our stock antibody solution, which has a concentration of 250 milligrams per milliliter, and mix this with 4.85 milliliters of our diluent to bring the total volume up to our 5 milliliters that we require. Now moving on to our second example, a student accidentally pipettes the wrong volume of glucose into water, and instead they mix 500 microliters of 1 millimolar glucose with 4.95 milliliters of water rather than the 50 microliters that was stated in the practical proforma. The student wants to know what is the concentration in millimolar of the diluted solution that they accidentally created. So in order to do this, we need to bring up our equation and then rearrange it using basic algebra to find our C2 value, which is the concentration of our diluted solution. And this gives us C2 being equal to C1 times V1 divided by V2. We can then start to transfer all of the information from the example into our equation, giving us C2 equals 1 millimolar times 500 microliters divided by 4.95 milliliters plus 500 microliters. And as you can see, we need to calculate our V2 value as it isn't expressly given to us in the question. Now before we can simplify this, we need to make sure the values within the equation are using similar units of measurement so that they can eventually cancel one another out. And so we need to convert our microliters into milliliters. And this essentially gives us an equation of C2 equals 1 millimolar times 0.5 milliliters divided by 4.95 milliliters plus 0.5 milliliters. Now to make things easier, we can start to simplify this equation by completing the bottom line of the equation, giving us C2 being equal to 1 millimolar times 0.5 milliliters divided by 5.45 milliliters. We can then simplify this equation again by completing the top line of the equation, giving us C2 being equal to 0.5 millimolar per milliliter divided by 5.45 milliliter, which we can complete to give us a final concentration of 0.092 millimolar, which is the actual concentration of the solution the student created. Now, had the student used the correct amount of solution and worked their way through the example, they would have created the desired concentration of 0.010 millimolar. And for anyone that is interested, the student could theoretically use this 0.092 millimolar glucose solution to create the desired 5 milliliter 0.010 millimolar solution, and applying the same equation, rearranging to find C1, we would essentially mix 0.543 milliliters of the 0.092 millimolar glucose solution with 4.457 milliliters of water. And with that, we come to the end of this basic laboratory calculations video. Hopefully you found this content useful, easy to understand, and can use it going forward during your data analysis. Thanks for watching, stay safe, and I hope you have a great day.